So I'll just give a small introduction and then we can go on. This webinar on how to deploy machine learning model on cloud computing, on cloud. So this workshop will be conducted by Mr. Hassan Siddiqui, who is a data science and machine learning expert. He has more than 10 years of experience in the field of data science and machine learning. He has worked with numerous organizations such as Kotak Mahindra Bank, HDFC Bank, American Association. He has skill and data warehousing and firm understanding of relational and non-relational databases like MySQL, MS SQL Server, Postgre, MongoDB, Cassandra, etc. So, sir, welcome to the session. And over to you now.
Thanks for the warm introduction, Suresh. So welcome to the live session, on how to deploy a machine learning model on cloud. Okay, let me just, this is about, I think, about the Intellipaat. I'm not sure if you have heard, what all we do as an Intellipaat team. So it's a highly, world's leading education provider. We have subject matter experts who teach, all machine learning or deep learning courses, right? And we are available in all these many countries, and we have tech support, which is available 24/7, right? So I think before talking about these key features, I think it is better, for me to display what is today's agenda. Okay, what machine learning is, right? Machine learning and DevOps, all right? So this is the agenda today. So we'll first learn what is MLOps, which I just described you briefly. Right? Second is, why do you need MLOps? Okay. The third point is process of MLOps. What is the current architecture and MLOps process? And finally, we look at the deployment part of the MLOps in Azure Machine Learning. So what is MLOps? So if you look at this slide, it essentially talks about same thing which I just spoke about, the DevOps part. Okay. The DevOps for machine learning model is nothing but your MLOps, okay, and which is a process for developing models for production. Okay, so whatever model you build, you eventually have to deploy it, right? So that you keep on scoring it in a new point, or you keep on predicting on a new data set. So you have built your model on a previous time, on historical data, and then you are now in a position where you have deployed it to predict future. That is where your deployment part comes in, right? So this is a process. The MLOps is a process for developing your models for production, so that you can predict in future, right? And this is what your life cycle, if you look at this graph, see your model's life cycle looks like. Okay, you start from your data, you start extracting your data from different sources. It could be internal source, it could be external source, and then you finally take this entire data to train your model. Okay, where you try to select what kind of model you want to build, whether it's going to be a classification model or a regression model, and then you train it. After you train it, you eventually deploy it, correct? So that you can predict this model which you have just created in future. And then you monitor this model, whether it's performing well or whether this performing is not working well. And finally, whatever is the outcome, you decide your next step according to that. So again, you take that feedback, feed it into your updated data, and then again retrain your model if it is required. So this is what your entire MLOps architecture looks like. Okay, or this is, I would say, rather, this is the ML life cycle. This is what a general ML life cycle looks like. Okay, and this is where MLOps will feed in. So where will MLOps fit in? So MLOps, generally, it is a set of practices for collaboration and communication between two parties. What are these two parties? It is data scientists and operations professionals. Okay, so this MLOps, which you have just, you can call it a process, you can call it a practice. It is generally for collaboration and communication between these two parties. So data scientists build this model, they train it, and then when they deploy it, they interact or communicate everything, all about this model with the IT professionals, all the ML or the ML engineers, to check if this model which they have just built can be deployed, or what is the feasibility. If not, it cannot be applied. So all this communication becomes very much easier and smooth when you have MLOps in picture. All right. Now, in second line, you can easily see what it is saying. It's saying applying these practices increases the quality, simplifies the management process, and automates the deployment of machine learning and deep learning models in large-scale production environments. Okay, so here you're increasing quality as well, right? Because previously, for example, you started with your model development, okay, and then in general scenario, this entire model development, it takes around maybe 50% of your entire time, and this maybe in India, I would say, it generally takes a lot of time. The significant amount of time is, first is went into model development, and the rest of the time it goes into model deployment. So there's a huge time. If I can put it in an average term, you take around a month time to build and deploy your entire ML model. But if you have MLOps in picture, if you have MLOps fit in your maybe operations, then this entire cycle becomes very much easier. It's very much faster, and that's why it increases the quality. Okay, it simplifies the management process, and now since you've automated, the deployment is also very much smooth, right? Even when you have larger data now, it gets taken care of. Now, so we'll look at some examples so that you understand this even better. Okay, so but this is what in general what MLOps is. Now, why do you need MLOps? All right, so MLOps, as I say, it is about machine learning. But what machine learning is, it helps individuals and businesses deploy solutions that unlock previously untapped sources of revenue, save time, and reduce cost. So this line is talking about your machine learning. So this is what a machine learning does, right? So when you build a model, suppose you build a classification model, all right, and after you build your model, what eventually you get is maybe a likelihood or a probability for each customer. Suppose you are maybe a DMart store, all right, and you want to know whether this particular DMart store has maybe a lack of customers, all right, and now the DMart store wants to only put or target those customers for communication who have high chance to come back to their store. Okay, so they do not want to, they do not have that much money which they can put in communicating those entire lack of customers. So they only would want to target or communicate to those customers, maybe send email or SMS to only those customers who have very high chance to come back to their store. So now what happens? You are saving your time, okay, by not communicating to all those customers who are any which way is not going to come. You're saving your cost as well, correct? Because even if you have communicated, that person is any which way is not going to come, correct? So you're saving time, you're saving cost. And how do you do it? You build a machine learning to do this. You build a machine learning model to get a probability for each of the customer, and you can use this probability to decide, okay, these are the customers who have a very high chance to come back to my store. I'll only communicate, or I'll only send SMS or email to this set of customers, and I will not communicate with who have a very low chance or low probability to come back to my store, correct? So this is what ML in general does. I'm not talking about ML ops, I'm talking about ML in general. Now, and automating this ML thing, automating this entire model development with machine learning development and deployment with ML ops, this means faster go-to-market times and lower operational cost. Okay, now ML is already helping you in by saving time or reducing cost, but if you include ML ops and automate this entire process of development and deployment, now the amount of time which you were taking to build this entire model, which was maybe probably a month, now you only taking maybe a 4 days time or a week time to just build this model and deploy it quickly, right? So there's a faster go-to-market times and lower operational costs, so that you do not have to again spend time or call your data scientist, okay, I need some change in my model, can you please rebuild or refine this model on a different data set, and again give me some predictions. If such kind of requirement comes, MLOps will be very easier for you to refine this model and quickly make it for production, right? Otherwise, it would have been very difficult. You would have again taken a lot of time to again develop this model, redevelop this model, and again redeploy it. So you are taking a much faster mode of method. Now MLOps, it serves as a map to guide individuals, the small teams, and even businesses to achieve their goals with minimum troubles. Besides this, these are the 4 issues, the 4 charts which you are saying. These are 4 major issues which generally comes in a ML cycle. Okay, and MLOps helps us resolve all these issues. So what are these issues? These are basically deployment issues, your monitoring issues, your life cycle management issues, and your model governance issues. So what are the deployment issues? So sometimes you build your model on your local environment, maybe on your PC or on your laptop or any of your company given systems, and then when you start deploying it, you come to understand, okay, I will probably not be, you have built a good model, okay, no doubt, but when you go for deployment, you come to know, okay, I will not be able to deploy because there are some constraints at the deployment part. Maybe the IT team is saying, okay, you have maybe a bank sensitive data, and we cannot use those variables which you have used in your data, so we have to change some variables, or maybe you have used some Python packages or a version of packages which are not compatible with the versions which IT team has. So there are a lot of issues, such kind of issues, which may come when we compare your system's configurations and environment compared to what IT team has or the ML engineering team has. So there are a lot of deployment issues. Then there is monitoring issues. So when you develop your model and then you deploy it, after that you also have to monitor, right? That whether your model is performing well or whether you're performing not well, like that, and then you feed that in your data. But there are many times you do not get that data, you do not get those feedback, and you are not able to even properly monitor if your model is working fine or not, because probably it is not getting targeted the way you want it. So you have built your model and you deployed it, but the target which happened based on your model is not happening according to the plan. Okay, so there are a lot of monitoring issues as well, because there is no set pipeline which is helping you to get this maybe data quickly so that you can feed that into your model and retrain and redevelop. Then again, there is third part, which is life cycle management and then model governance issues, where you're trying to manage entire life cycle. So the entire life cycle is only having issues. Your training might have issues, your development might have issues, your monitoring might have issues, and again feedback might have issues. The entire life cycle might have some issues because you're not able to manage it. So that's why life cycle management issue comes in. And finally, there is model governance, where you kind of look at how your model can be governed. All right, and so model governance is basically you're checking all your again, it is similar to your monitoring, but it is basically checking all your performance if it's going well or not. All right, so there are a lot of issues which all these areas which can come in your model development cycle, and your MLOps can help you resolve all these. Correct. If I can give you one example, let's look at maybe an example of Netflix. So when you log into Netflix, you see that there are certain recommendations provided to you. Correct. Now, I think by now you have already, must have had this example in your somewhere, maybe in your if you have Googled it, searched it somewhere, or if you have attended some session. Netflix is one of the example where ML is generally used, where Netflix basically uses ML to provide you some recommendations. All right. Now, these recommendations are good. All right. But if you focus on the recommendations, when you log into your Netflix, you see, okay, these are my recommendations. And again, after you log in, maybe a couple of hours, you see the same recommendations. You do not see a different recommendation. But if you log in maybe after 4 hours or 6 hours, or maybe after a day, you see the recommendations are now changed. Correct? So you must have observed this. So now, if you think of this example, maybe from other angle, suppose you log into your device on Netflix, and then after a day, or after a 2 day, or after 3 days, you are seeing the same recommendations. So which one is worse? Obviously, the second one, where even after 3 days, after you have provided so many inputs to Netflix, the Netflix is not able to probably give you those kind of recommendations which you have just given them, right? You have given them some of your behaviors which Netflix could have used to build rebuild your ML model, and then provide you some latest recommendation. Okay, so there are two problems. Correct. Netflix has identified the second problem, probably because now they have MLOps in picture. All right. Now, if you remember what I said, an example where you're taking probably a 15 days time or a month time to build your entire ML model. If Netflix would have done that, you probably even for a month time, you would have seen the same recommendations, right? Because Netflix on basically you have given suppose you're logged in Netflix, okay, and you given them some impression that you have clicked on this video, you have clicked on that movies or some other TV series. Okay, now what Netflix will do, if they do not have MLOps, they will take all these behaviors. Okay, they'll prepare a data, then they will build a model, then probably test it on a different time point, and then eventually deploy it. Okay, my model is built. Now we can give this recommendation to this particular individual. Now this, since there's an absence of MLOps, would have taken a month time. But since they have MLOps in picture, all right, what they do, they quickly they have all this set it up in one pipeline. Okay, so that as soon as you give this impression or all these behaviors to them, they use this, and again quickly it gets refined, or in their ML model, the ML model is quickly again rebuilt, and quickly the recommendation provided probably after maybe a couple of hours or after 4 hours. Then after you log in, maybe after 4 hours, you see a separate recommendation. Correct. So there is some process, some automation done at Netflix's end, which they are using, to give you a very on-point recommendations. Now, obviously, this MLOps, this process, this automation can be more better. Right? Maybe you can maybe say, okay, why 4 hours? Maybe as soon as I give them maybe a behavior or an impression that I clicked on this, the Netflix should be able to give me or provide me recommendations quickly, correct? So Netflix probably is lacking in that part. But if you imagine Netflix is trying its best, because if they try to do this, there'll be a lot of bandwidth issues for the entire world. That's what they claim, because obviously both of these examples will have MLOps, but the one which you are thinking of might not be possible at today's time, because there'll be a lot of bandwidth issues which they will have to solve for, so that as soon as you click on something, that video is available at that time, and whatever recommendation they're providing, even when you click on those recommendations, those should also run similar speed and probably also be available to you. Okay, it's not that if when they recommend it and when you click on it, it is not running for you. So that everything they have to make an arrangement so that nothing goes off. So that will be again a very smart MLOps, but again there is some MLOps which is in place from Netflix side, which is providing you a recommendation when you probably log in after 4 hours or 3 hours. Right? That is one of the example when Netflix faced some issues and deployment issues. There are still some issues, but still they have resolved it using MLOps. So this is a complete MLOps process. All right, it is divided into 3 broad phases. All right, first one is the design phase, second is the model development phase, and third is the operations phase. What is design? Design is basically where you put all your requirements, all your data. That before you develop your model, you first take your data, right? First you extract your data maybe from internal sources or external sources, and then you see that, okay, what kind of model can I build here? So before you build your model, you first decide all this, and you first design your entire framework. You put an approach that these are my requirements. Okay, I would require a data that should be maybe coming from X or Y sources. I would require this kind of models. Okay, and these are the other requirements. Maybe you would require latest packages or latest maybe functions or latest maybe Python tools like that. Okay, so those all things will come as an approach to you in a design phase, the first phase. Then you use this design to put everything in a structured format, and this becomes your framework. All right? And then eventually you go to your second phase, which is your model development. So once you're done with your design, you start working on that design where you build your model. And how do you build? This is a regular procedure which we just saw in the first couple of slides. You do your data engineering, you do your model engineering, and then you eventually test your model and validate the same. What is data engineering? So data engineering is a general procedure in model development where you try to work on your data, you try to munge your data, you try to make your data more structured, you put in a more structured format, you clean it, you make you make all those kind of features available to you which would be required in your model development phase, and prepare it basically your data in such a manner so that it can be used or it can be consumed in your ML model in a very structured manner. Okay, so this is what a data engineering part, where as I said, you clean your data, you maybe doing a missing value treatment, your outlier treatment, you probably do your univariate bivariate analysis, maybe do your outlier treatments, as I said, and then you do some kind of feature engineering. These are kind of variables I would require or I would not require, like that. So you do all these activities which will be called as a data engineering activity. And then you move to your ML model engineering, okay, where you select your model which you have done in your design phase, and you start working on those models. If it's a classification models, or you can start building your multiple classification models. Maybe you start with a logistic regression, and then you move on to maybe a random forest or a decision tree model. You try all those models, and then you see which one is giving you best performance, and accordingly you move to the next step, which is your validation phase. So once you have built your models, you test it and validate it, whether this model is stable enough or not stable, correct? So once you build your model, first you also have to check it that whether this model which I have just built, whether it is giving a similar performance in a test or validation phase as well, correct? So this is also a part of this entire development phase, so where you develop as well as validate your model. All right. So once you're done with this, the last part comes, the last phase, which is the operations phase, where you deploy your validated model. All right. So you deploy or create a web service which will deploy this or make it available to predict the things or predict for the customers for the near future. Right? And how is done? It's done generally through a CI/CD pipelines, which we spoke about, right? Continuous delivering, where everything is set up like in a pipeline. As soon as you put anything in your in your deployment, quickly that entire row or entire observations are quickly predicted, that whether this customer, suppose, will come to your store again or not. So you'll quickly get a probability which you can use for your communication. And then finally, there is monitoring and triggering, where you monitor, and again, if something goes wrong, it triggers you, and then again, you use that feedback and then rebuild your model. So this is what your entire process of MLOps looks like. You start with design, you develop, and then there is the operations part where you deploy your model. So this is what I spoke about. Let's quickly look at this entire 3 phases. What these are. Okay, the first phase, as I said, it is devoted to business understanding, data understanding, and designing the ML powered software. So in the first phase, since it's a design phase, you first understand what the entire business problem is. Correct. So you first understand whether this is even a problem, or if it's a problem, how big the problem is, and if it can be solved using a classification algorithm or a regression algorithm, or if any other algorithm. Right. So you first understand the entire business problem, and accordingly decide which model or which ML model would you want to choose. For that, you would also require data, correct? So you do all these activities, you full understand the business, you understand what kind of data will be used, and then eventually you design this for the entire ML process. Now, in this stage, we identify potential users. So this is talking about your data, basically. Okay, we design the ML solution to solve this problem and assess the further development of the project. Mostly, we would act within 2 categories of problems, either increasing the productivity of the user or increasing the interactivity of our application. So what this is essentially talking about is, when we build a model, we generally are looking at 2 things to increase. Either we are trying to increase our conversions or increase the productivity of the user. What this means is, suppose every month you were getting maybe 100 customers coming into your store. Now you want to increase this number, right? You want to increase 100 to maybe a 200 or a 150, right? That is the first thing which generally companies look at, where they're either trying to maybe increase the productivity, or they're trying to increase the overall conversions, correct, which is happening per month. Or second thing is increasing the interactivity of our application. So second is basically talking about the engagement part. I'm just giving one example. If I can give you an example for both of these categories. First one is, I just gave you that the model can be built either to increase the number of conversions in a month, or you're trying to increase the overall customer engagement, correct? So you're not concerned about the number of conversions, but you're concerned that how much your customer is engaged with you, whether they are coming back to your website, whether they're clicking on certain banners like that, or they are not just buying one product, but they're also buying multiple products like that. So this is where you talk about the engagement of the your entire set of customers. So there can be only 2 categories generally where we are trying to use ML model to solve it, correct? Now, initially, we define ML use cases and prioritize them. The best practice for ML projects is to work on one ML use case at a time. So this is the best practice. You need not build or work on multiple business problems and start building multiple ML models differently for all those models, because sometimes it gets very tedious for you, and you might not be able to build a very optimal model because you're doing this for to address multiple business problems. So you might get confused and probably apply one solution to other solution. It's better to have one model which you're working on at a given time, right? Furthermore, the design phase aims to inspect the available data that we will need to train a model, correct, and to specify the functional and non-functional requirements of our model. This is all about the data which you will require to train your model, and to specify the functional and non-functional requirements of your ML model. So what ML is all about your ML model. So what maybe packages you would require, what tools you would require, all these things. So this will all be coming in your design. Lastly, we should use these requirements to design the architecture of the ML application, establish the servicing strategy, and create a test suite for the future ML model. Right? So you basically, eventually after you build your model, you put it in architecture that, okay, this is what I'm going to do. I'm going to train on this. I'm going to use this data set. I'm going to predict on these. I'm going to use these many features or behaviors of all the customers. And then eventually I'm going to create a service which will predict for any new given customer, whether this customer will step in my store or not. This is the second phase where it is talking about the model development, and this is nothing but which we just spoke about, right? And we run iteratively different steps. We try to come to the best model possible using multiple iterations, and which involves all the data engineering, your model engineering, and lot maybe hyperparameters, like all those stuff. We're trying to do many stuff in this model development phase, where the objective is to arrive at a model which is very stable, where basically your train performance, for example, if your accuracy of train performance is 80%, you try to see if your test performance is also coming in the similar scale. Okay, see, mostly we try to see if your train performance is 80, your test should at least be within plus or minus 5% of your train performance. Okay, so basically we are checking if your model is a stable model or not. And this is how we check it, that the train and test should be coming in a similar scale. All right, so this is the objective, and then we try to solve it using all these methodologies like data engineering, model engineering. And finally, when we get a quality model, we deploy it. And how do we deploy it? This is the final phase. The main focus of the ML operations phase is to deliver the previously developed ML model in production by using established DevOps practices such as testing, versioning, continuous delivery, and monitoring. So this is exactly the same thing which we just discussed, right? So we are establishing DevOps practice by testing everything which is possible. Suppose we have built a model in a different environment. So first we check if the same environment is available or not, or if it is not available, we have to create that environment, maybe some good best practices, maybe by containerizing, or maybe using Kubernetes, all those stuff. And then when we have such environment, we version it, and then there's continuous delivery which is happening. So your entire cycle is basically now automated, and there will be a continuous delivery because everything is now set up in a proper pipeline. Okay, and then finally, once you're done with the continuous delivery thing, then you start monitoring it, and then whatever is the monitor results, you take all those results, and then you feed it into your model, and then rebuild your model to get a more stable model, because now you know that where exactly your model failed, because you have set up such a good pipeline in front of you. Correct. So now whatever is the result, whether the model is performing well or not, or where exactly it is failing, you can use those feedbacks and put it in your model and then refine your model. So all these three phases, they are interconnected, okay, and they influence each other. For example, the design decision during the design stage, it will propagate into the experimentation phase. Okay, so as I said, the example which I just gave you, right, the monitoring one. So you can take that, and then you can put it into experimentation, that whatever is the monitoring result, what is not working and what is working, you can put it into the experimentation phase, and then you can try different experiments to refine your model more. Right? That is the objective. So finally, you influence the deployment option during the final operations phase. Okay, let me check one of the questions before we proceed. Is any model built-in? Okay, the question is any built-in ML model available only to use this ML model according to our requirements without coding? Secondly, which programming language is best suitable to create ML model besides Python? All right. So it depends, okay, I'll answer first question, which is basically, is any built-in ML model available? So there are a lot of models available, not built-in model, but there are a lot of models which is available in whatever environment or whatever service which you're using. Suppose you're using a cloud service like maybe an AWS or Azure, so there will be a lot of models which will be rightly available in front of you. And if you want to, let's say you have a problem where you're trying to build a classification algorithm, you can choose any algorithm from all those models and proceed accordingly. The options which you have is whether you have to go with a no code experience or a without coding experience. In no code or with coding. So no coding, basically where you just drag drop all your entire process. Okay, you can just drag drop your data which you want in your model. You can drag which kind of models you want to build, and what type of explorations or cleaning or engineering you want to do in your data. You can just drag drop all those nodes and build your entire model by just drag dropping. That is a step availability which is there in your AWS or Azure, which you can do if you do not want to code. If you want to code, there is a notebook available where you can code either on the notebook or on the .py file to again do the similar activity. So you have both the things available. But if you're working on maybe a local environment where you do not have AWS or Azure, and you only have a tool which is available in your system, So you can now, obviously it is now up to you which model you want to build. You can communicate with your IT team if you do not have some packages, and you can install those packages and build a model according to your wish, right? Does that answer to your question? All right, the second question was, which programming language is best suitable to create ML-based ML model besides Python? So there is, so it depends, first of all, which organization you're working on. Sometimes even when the other language is available or it is more suitable, it is not available in your organizations, correct? So if in general, I would want to answer, there is R language, there is Julia, all those things are there. Then there is very new, I think, tools are coming into picture, but right now Python is leading. I would request if you can have a good hands-on experience with at least 2 tools, if not just Python, so that it is very easy for you to work on any of them, whichever is available in your organization. Okay, so coming back to this slide. So this slide we completed just to understand the entire the process of MLOps, okay, which largely has 3 parts, like design, development, and your operations phase, where you eventually deploy your entire model. So let's understand the machine learning pipelines, all right? Because we just saw what are the phases. So how do we connect these 3 phases? So these 3 phases are connected. This is a pipeline. Okay, what are these pipelines? These are called ML pipelines, which are portable, okay, scalable ML workflows based on containers. All right. So first word is portable. So it is basically you can move this pipeline anywhere. Suppose you have built this model or this entire framework in your local machine, and you want to move this entire pipeline into some other place. So this is basically what the portability means. Okay, so you can move this pipeline anywhere. You can move it from local to web service, or maybe a cloud service. And from cloud, you can move to some other cloud service, like that. So it is very much portable. Then it is scalable. ML workflows, even if you have sometimes a larger data coming into picture, but you have worked on a very limited amount of data when you had built your model, but now your model is scaling. It is now having more number of features, more number of records, or more number of data. Suppose you have it just start coming. Now the model is able to also work on those scalability. So even if your model scales up, your still pipeline is able to take care of all these activities. And this is based on containers. So as I said, so even if your environment gets changed, container gets takes care of all this thing. So it will basically put everything, all the requirements which were there in your when you build your model. It will combine or package all this thing in one container, and then it directly move this thing to a different environment so that nothing gets changed. Okay, that is the benefit of containerization. Now, ML pipelines are composed of a set of input parameters and a list of tasks. Each task is an instance of a pipeline component. Okay, so this ML pipeline, as it says, are composed of a set of input parameters and a list of tasks. So the entire pipeline in each step, in each phase, basically you input your parameters. So this is the thing. These are the things. Maybe if it is talking about the data sources, these are the data sources which will be required in this phase. So you input all these things and just connect that node into a pipeline, and that will be set. That's it. And then you just set up. This is the list of tasks which I want to do, and then you keep it in such a manner so that everything is a very smooth. The entire pipeline knows that it has to start from here, and it has to end from the this last task which you have just mentioned. So it's like if you remember your computer programming, maybe workflow, it used to be like that. There's a start and there is end. So this pipeline is nothing but like that. You start with some input parameters, and then you have a list of tasks to do that. If yes, then do that. If no, then reverse the process or do some other activity like that, and eventually it ends up, right? This is what your pipeline looks like. Now, ML pipelines can be used to apply MLOps strategies to automate repeatable process. Okay, so if you want to repeat this process, suppose you want to repeat ML development or a model development process again and again, maybe on a different data set. Okay, so there your MLOps will be very helpful for you. Correct? To this MLOps process, it will help you automate this entire thing, because suppose you were not able to do this before, like what the example which I gave you. It takes a lot of time. Why it takes a lot of time? Because the data scientist has to come back or go back to a step where everything was not set Okay, everything was not set because there was no pipeline, and the data scientist has to again extract those data and again prepare those data sets to build that model, and again clean it and do engineering and do feature engineering and prepare it such a manner that it is like a replica of the previous model, and then again retrain that model and eventually deploy it. So it will be a very hectic task for a data scientists, which they are also currently doing, because there are many industries or many companies which still do not have MLOps in place. Okay, I'm talking about the Indian companies. Okay, so there's still this issues which are still there. Now, if you have this MLOps, it will automate this entire it will automate this entire repeatable process. So if you have any requirements which comes at any point, you can easily manage because you have a pipeline set in front of you. So you can suppose it is like it starts from node A, goes to node B, then goes to node C, and eventually node D will give you the deployment answer. So whatever is the requirement, you can just feed that requirement into any node and then change and just rerun your entire pipeline, and your pipeline will quickly run, and eventually it will be deployed quickly. Okay, so you're saving a lot of time and saving a lot of tasks, and eventually you're basically you're automated the entire process. So there is no chance that you will screw up with the accuracy as well. So now you're also solving the model accuracy part, because now the thing which you're doing before that, you're going back a step and again retesting and checking your model. Suppose your model was not giving a good performance, you would have said that, okay, my model is not able to give performance. Now you might have gone wrong in some step, but now with MLOps in place, which is now automated, it is not taking care of all this thing as well. Okay. Now experiment by running an ML workflow with different set of hyperparameters, number of training steps or iterations, etc. Okay, so there is an experiment also which you can do in ML workflow, correct, with different sets of hyperparameters. Like for example, suppose you build a decision tree model or a random forest model, you can easily specify what hyperparameters you want, where you can say, okay, ask a random forest that, okay, boss, you first start building your model by taking maybe 500 number of trees, and then maybe 5 depths or this many records, and build one model. Then you do this again for a different combination. Maybe you again build random forest by using 200 number of trees and different number of depths, like that. So you provide different hyperparameters and ask your model, a random forest model, to build a model on all these combinations and eventually give you a best performing model out of all these combinations. That is what your hyperparameter is, which you will again anyways cover in the next slide in detail. So this is an experiment which you can do in your ML workflow, which can be used in your ML pipelines as well. So whatever is the ML step or machine learning step which you do can be automated or can be used in ML pipelines. It can set up in such a manner so that everything is set or looked connected in a pipeline manner. Okay. Last step is reuse pipelines workflow to train a new model. So the pipeline, as I said, is connected in such a manner which can reuse to train your new model as well. So what are the pipeline components? Pipeline components are self-contained sets of code that perform one step in a pipeline's workflow, such as data pre-processing, data transformation, model training, etc. Okay, the components are composed of a set of input parameters, a set of outputs, and location of a container image. Now, this is what we just spoke about. Okay, this is just a description of what I've just said. Okay, a component's container image, it is a package that includes the component's executable code and a definition of the environment that the code runs in. So this is again a component. This entire thing is again a component of the pipeline. Okay, your container image basically it saves all the packages, everything which is required in your deployment. So as I said, suppose you have built a model in a different environment where there is some executable code, there are some packages, there are some versions which you have used in your model development. So this container image will take care of all this thing. Okay, it will create a package that will now include all this executable code and definition of all the environment that the code was run in, and then it will again be used in a pipeline. So that when anything which comes in as a new record, it will automatically taken care by this container, so that even if there's a new environment or maybe version in which is there in your IT at your IT end, it will automatically get taken care of by the container image. Right? So this is all can be set up in a pipeline manner. Now let's see what is a hyperparameter tuning. Okay, before we see the hyperparameter tuning, we will first understand what is hyperparameter tuning. So hyperparameters is exactly what I now just told you about random forest thing. Okay, right? So these are ones which contains the data that govern the training process itself. Usually, when the training, while training the model, the training application handles three types of data. Correct? There is some input data, there's some model parameter, and then there is hyperparameter. Now, all these three types will change according to your model. Your logistic regression, for example, will have some other input or some other hyperparameter. Your random forest will have some other input data or some other hyperparameter, right? So all these things are called hyperparameters, which you can change for each of the model. Correct? So what is this input data? It is used during training to configure your model to accurately make predictions about new instances of similar data. Okay, so you have to input some data to make predictions as well. Correct? That data is called the input data. In your development phase, this input data was your train data, correct? But apart from that, there are also other instances which you can create. For example, in logistic, if you run it in a Python, you will see when you create this instance, which is logistic regression, and then you put a 2 round brackets, which is basically creating a new instance of logistic regression model, which you can use to train your model. So when you do this activity, when you do create this instance in those round brackets, you can input your multiple input parameters. That is what your input data is. Okay, where in logistic, for example, you can input your penalty method, your penalty parameter. You can change your penalty. You can basically penalize your betas and solve the problem of overfitting. Now this parameter will not be available in your random forest. Right? Random forest, you have a different parameter. So the input parameter will be changed. Correct? So this is what your input data is. Second is models parameter. It differentiates your particular model from other models of the same type working on similar data. So this is again a similar parameter which I just spoke about, like L2 parameter, right? First one was the input data, which again where you have train data and you create an instance, and model parameter is then passed in your input instance. Okay, so the second step is again a sort of connected to your first step. Then eventually there is hyperparameters, which we looked at in previous slides, where you have something called as grid search, and you ask your model to perform different kind of models on all the objects or on all these combinations which you have asked that model to work on. For example, in random forest, we saw that we can ask model to use a grid search to build model on maybe 500 trees and then give you performance, and then again rebuild your model on 200 trees and then give you a performance, and then again keep on doing this until you say that okay, you stop at this combination, which is maybe probably at maybe 50 trees, correct? So you're asking your model to build multiple random forest models on all these different number of trees, and eventually give you or tell you that which combination gave you the best result. That is the hyperparameter concept. Right? So there are three things: input data, models parameters, and the hyperparameters. How hyperparameter tuning works? It is the same thing which I just spoke about. It works by running multiple trials in a single training job. Okay, each trial is a complete execution of your training application with values for your chosen hyperparameters. Correct? So it is the same thing which we just spoke about. And now, eventually, if you look at the bold section, which is last paragraph, hyperparameter optimization or hyperparameter tuning can be a tedious task, right? Because you have to, you don't know, first of all, which hyperparameter you should tune. That is one question. And then you also have to, again, take care of all these coding part as well, that okay, I have to ask random forest to use this maybe hyperparameters to tell me which model, which combination is working best out of all these combinations, correct? And when if something goes wrong, something is not working out, you again go back to grid search and you say that okay, I tried 500 trees, 200 trees, 100 trees, probably I did not try 50 trees. Let's try adding that as well, and again ask random forest to build multiple trees and eventually give me that which model or which combination is working best. Correct. So this is where your Azure machine learning can help you out. You can automate this task for arbitrary parameterized commands with just little modification to your job definition. Correct. And in Azure, as I said, it is basically helping out in automating this entire task. So it is helping out in doing this tedious task, and which you can do it easily in Azure. And this is something which can be visualized in the Studio. So we'll look at what Studio is. but this is what the Azure machine learning basically does. Okay, let me look at some of the questions. Okay, so there's one question: how can test and train the model with Newton ops environment? Okay, so Sumit, once you have set up a pipeline, okay, you can easily test and train because everything is in front of you like a node, right? So you can change the node and change your input data and again rebuild your model whenever required. This is how fast it can. Okay, so let's see what is Azure machine learning. So Azure machine learning is a cloud service for accelerating and managing the machine learning project life cycle. Okay, so it is basically a cloud service. It is very similar to your or exactly same like your AWS, which is Amazon Web Services, right? So there are a lot of cloud service platforms which are available today to us, okay? And Azure Machine Learning is one of the cloud service which is helping us accelerating and managing the entire ML project life cycle, correct? So Azure Machine Learning is basically, it essentially talks about your MLOps, all right? And that's where it accelerates and manages the entire life cycle. So previously you're building your model or maybe for a 15 days period of time or a month period of time, and whenever a change used to come, it again used to take those many days to rebuild your or retrain your model, correct? So you have now accelerated this entire process because now you have set up an MLOps process. And how have you done it? You have used Azure Machine Learning to take care of this. All right. So this is a cloud service which is helping you out in accelerating this entire life cycle. This ML professionals, data scientists, and engineers, they can use it in their day-to-day workflows, train and deploy models, and manage MLOps. So you'll probably understand when I now show you the deployment part in Azure Machine Learning. This will be then more clear. Now you can create a model in Azure Machine Learning or use a model built from an open source platform such as PyTorch, TensorFlow, or Scikit-learn. So you can build a model or create a model within Azure Machine Learning platform, or you can use a built-in model from an open source platform. So suppose you have already built a model using PyTorch or TensorFlow or Scikit-learn, you can again connect from Azure Machine Learning to that particular platform and just directly use that model in Azure Machine Learning, and then you can use this in your pipeline, and again you can see what tweaks you can do, if you can improve that model, or if you can directly put it for deployment. So MLOps tools, it helps you monitor, retrain, and redeploy your entire complete model. So this is what your Azure Machine Learning project lifestyle looks like. It can vary by project, but the common life cycle will look like this. Okay, so you first define the task, what you want to do. Okay, whether you want to build a model, a classification model or regression model, or just maybe an exploration kind of thing, right? So you first define the task, and then eventually you start with your data exploration part, where you try to do maybe a univariate bivariate analysis, and you try to understand what your data is, correct? And then you move to your train and validation phase, where you select your model, and then you train it, be it classification or regression, and then you validate it. So you test the stability of the model and the performance as well. So that your performance, your stability of the model is also there, and your performance also maximum. Correct? That is the whole objective of the train and validate model. And then eventually you deploy it, right? You put it on production and you see if you can predict it on a new time point or for a new set of customers. Then here what MLOps comes into picture, where it is trying to monitor and manage your entire life cycle. So it is now connected with the pipeline, and then you can, whatever the result is from the monitoring, it can directly be fed in your data part, and then you can use this as your probably a new feature or variable, and then you can use this in your again retrained model. So you retrain it. This is the new feedback which has come after you've monitored it. Okay, and then you can retrain and again redeploy it. So that your model, there's a continuous process, okay, which keeps on happening. We're continuously trying to improve your model. So you're continuously trying to maximize your model's performance. Now, what is machine learning? Azure Machine Learning Studio. All right. So this is, if you look at this screenshot, this is the first page of your Machine Learning Studio in Microsoft Azure. Okay, it is a web portal for data scientists, developers in Azure Machine Learning. The studio, it combines both experiences, no code as well as code first experience for an inclusive data science platform. Okay, so it has generally, when you go to this particular studio, you will generally see, these 4 tabs. First is create new, Then there is notebook section where you can have a code first experience. So whatever model you want to build, suppose you can build it in this notebook. You can start coding using this notebook. Or if you do not want the coding experience, you can move to automated ML probably, or a designer phase where you can have a no code experience where you will just drag and drop your entire node, whatever you want to work on, and then you can directly just click and connect those nodes to eventually build your model. And this is how your notebooks looks like. When you start coding, this is where you can just create a notebook, just add a file, and then it will open your Jupyter Notebook where you can print hello and see if that is working for you or not. All right. So this is where you can create a notebook and start coding. Okay. Now this is just not just one Jupyter Notebook. There's also a section where you can create a .py file as well. The only difference is in Jupyter, as you know, the output you get in a same page. Okay, the output you directly get after you hit run, the output gets below that particular code cell, correct? But in .py file, when you run that code, it will open in a new command prompt. That is the only difference. When you run a .py file code, it will run in a different command prompt, which will open as soon as you run that particular cell. That is the only difference. So you can code in both of them, but generally, the people find Jupyter as a more friendlier environment because you get result in the same page. And then you have a no-code experience where you can just drag drop your nodes, you connect your data, you clean it, or you pre-process your data or do some exploration, and then eventually you start building your model. So everything can just be done by just drag drop and connecting your nodes. And this is the automated machine learning where everything is probably can be done in a very short period of time. Everything is set up. There's already list of models available. You can just ask your Azure that okay, use these models and use these hyperparameters, and everything gets taken care of in a very quick shorter period of time. And this is the Azure machine learning architecture. Okay, so center of this is what is called workspace. So the first thing which you do in Azure machine learning is you create a workspace, right? This is basically a station where you're working. Suppose if I give you an example, when you go to your office, you sit at a workstation, right? This is nothing but that. So this is a workstation or workspace because you're working on cloud. It is not workstation, it is workspace. All right. So first you create a workspace, and what all other things are connected in this workspace? What all things you can do? This is the things which is mentioned in this particular slide. Okay. First row is basically telling you what all dependencies are there in this workspace, what all things you can do. First one is the Azure or storage account, where probably all your data sets are stored. Then there is container registry, where all your maybe packages or what kind of environment you have used, what kind of versions you have used, everything gets saved. Then there's Azure Key Vault, where all sensitive information maybe related to your account, okay, which you have created, it gets saved. And then finally your Azure application insights, where whatever ML model you have built, whatever results which you have derived or insights which you have derived from your ML model gets saved. These are the four essential storages or folders. Just a second, let me just, okay, sorry about that, my ride was here. So these are the four accounts or folders where everything gets stored. First is Azure Storage, then there's Container Registry, and then Azure Key Vault, and then finally Azure Application Insights. All right. So these are dependencies, probably you can say, and which is connected to your workspace. Then in the left-hand side, you will see there are two linked services. One is data stores, and then there is compute targets. Okay. What is data store? Data store is nothing but basically whatever data sets you create in your workspace or in your pipeline or in your model building process, it gets, when you register that particular data, it gets stored in your data stores. Right? Then there is compute targets. So these are all linked services. Okay, so you can use this data store. Suppose you have some separate data available at maybe a different platform, you can also use this data. So it's a linked service, okay, which you can use. And there's also again compute targets. Suppose there is a platform where you have more compute available, maybe probably more CPUs or more number of GPUs, you can directly link to that particular platform and use those services. Why we are using other platform services? Because sometimes we do not want to spend on our current compute, which is probably only having 4 GB RAM or some limited number of GPUs. So we do not want to use those targets or those computes. We want to use a compute which is much larger in size, and that is only available at different platform which we have anyway, and which we spent So I directly want to use that particular service instead of Azure services, which is compute instance on the right hand side. So I can directly link that to the compute target using linked services. All right. On the right hand side, you can see there are managed resources which is available in your workspace within Azure, which is compute instances and compute clusters. All right. What are these two things? We'll just cover in the next couple of slides or next slide. Okay. But before that, we'll look at the bottom row, which is your assets. Okay. So you can first look at the endpoint, which are the end results, and then there is models which you build. Then there is data sets which you again use to build these models. And then there is pipelines which you use to connect all these things, which is data sets, models, and endpoints. All these things are connected using a pipeline. Then this entire pipeline is then created as an experiment. Okay, but you can create a multiple experiments. Correct. You can build multiple models. You can create different kind of experiments. Suppose you wanted to use different kind of features in one experiment and different features in other experiment. Suppose you want to do some other hyperparameter tuning one experiment, and maybe a different model or different algorithm in a different pipeline in a different environment or different experiment. Correct? So there you can see you can have a differentiation among your experiments. So everything, pipeline, data sets, models, endpoints are now coming under experiments section. Then again, in this to create this entire experiment, I have to first create an environment. So you can look at all this entire row as a subset of each other. So endpoint is a subset of model is a subset of data set, which is a subset of pipeline, and again experiment and environments. So now let's look at the difference between compute instance and compute clusters. Okay, a compute target, first of all, is any machine or a set of machines you use to run your training script or host your service deployment. So it is basically talking about your CPUs and GPUs. Okay, you can use a local machine as well or a remote compute resource as a compute target. All right, is I think pretty much clear. And what are the difference between compute instance and compute clusters? Compute instance is a virtual machine that includes multiple tools and environment installed for machine learning. Okay, so this is rightly available. That is basically one virtual machine which is assigned to your job or to your model which you're just going to build. Okay, and it's installed for you. So you can just use that particular virtual machine having maybe 4 GB RAM or some SSD, right? Some GPUs. You can use that for your particular model, whichever you think will be enough for you to build this model. The primary use of compute instance is for your development workstation. But what is compute clusters? Compute clusters are a cluster of VMs. So there's not just one VM, there's a cluster of VMs with multi-node scaling capabilities. This is generally used when you have large set of jobs to be done or very large set of data which is available, and that might be real time or keeps on changing. So if there is some such kind of requirements, in generally we use compute clusters. Compute clusters, as it says, are best suited for compute targets for large jobs and production. Let's look at an Azure ML Designer demo so that you understand what we just spoke about. So, okay, let me again talk about this. In Azure ML Designer demo, we'll look at this regression problem, which is basically automobile price prediction. So this is an example. It's an example which is available in your Azure ML Designer. You can also go to Azure ML Designer by yourself, create your account, and look at this particular problem because it is available for everyone. Okay, this will have all nodes, all pipelines, everything available in front of you, which you can play around and see how different results you get and how things are very smooth and quicker for you. Okay, here we'll be creating a new pipeline. We'll import a data, we'll prepare this data, we'll train a new machine learning model, and then eventually evaluate a machine learning model, and finally we will deploy it for prediction. Okay, so let's So let's go to this Azure Machine Learning Designer demo and see how this can be done. Let me know if this is visible to all. Visible, right? Thanks, Ranganath. So this is a Azure portal. So you can just write portal.azure.com, and this is what you will be displayed. Okay. So here the first thing which you have to do, you have to sign up. You have to log in or sign up with your Microsoft account. If you do not have a Microsoft account, you can create one. All right, it's very simple, maybe a 2-minute job for you. Then once you create it, you can see that you'll have a page which is exactly like this. Right? On the right hand side top corner, you will see your name, your ID, and a default directory. So there are two things generally when you log in. It asks you whether you want to go for a maybe a free trial or you want to pay as you work. So there are two options generally which you can choose. You can start with a free trial probably and get just a hands-on experience, but eventually you will have to go for pay as you go, because nothing will be as similar when you go with pay as you go, because free trial is just there for 30 days. Eventually, in order to use any service of Azure, you will have to use pay as you go. But it is not very costly. It says pay as you go. So, but it gives you certain amount of free access as well. For maybe up till maybe 15 GB or 20 GB, you can work on or use these services free. But beyond that, you will be charged like that. Okay, so this is what your page is going to look like. Okay, and now since they're going to build a machine learning environment, we have to choose. We'll write machine learning. We'll create on this. Click on this. So this is what your page will look like. Now you can see there's nothing on this page. Okay, it says no workspaces to display. All right. So there is no workspace which we have created. And if you remember the last presentation which we are talking about, we create a workspace, correct? We create environment, we create models like that. So for that, we need to first create a workspace, correct? Which lies at the center of the entire modeling process. Let's create one workspace. When you click on create, this is the next page you will get. It will first tell you what subscription you have applied for. If you have a free trial, you will get a free trial written here. But if you have a subscription, it will say your subscription name. So whatever subscription name you have given, it will display you that. Okay, and then there comes resource group. So this entire thing has to first get created in a resource. So we just have to create a resource or give it a resource name. If you do not have a resource, you can create one, or you can select it from the drop-down menu. So if you do not have something, if you have just started with ML Azure, you will not have any resource group. You can just create one and give whatever name you want to give, which is suitable for this particular project. Then we have workspace details which you have to input to configure your basic workspace settings like storage connection, authentication, container, and more. You can give all. So basically, this workspace will handle or take care of all these connections and authentications and containers. So you can just put any workspace thing. Suppose we will write practice the MLOPs. Okay. So you can if you just write this, you can see the storage account and key vault and application inside. It will get populated by itself. Okay. So before that, you can see there is some region. Okay, you can select any region you want. Okay, it's not necessarily that you have to choose Central India only. You can choose any region. Sometimes some of the computes are not available. We look at what computes are. No, don't worry. But sometimes some computes are not available in certain region. You can change your region and see if you can have access to those particular computes. So suppose you want to access maybe a 10 GB compute and not 4 GB, and when you click on create compute, select that compute, it is not available in your region. So what you can do, you can go back to this particular workspace. You can create a new workspace and change your region. So for now, I have created Australian East, and see if now we are able to create a compute. Now I'll just you can click on next networking and see if everything works okay. So connectivity method public, it should be public. Then there's advanced tags and review and create. So we'll just go back to this one. Validation is fast, so I'll just create. Now you can see it says deployment is in progress. We'll just wait for maybe 10 seconds and it will be created. This workspace will now be created after we do this step. So see, if you can see these things are getting populated, it is still running, it is still in progress. But as soon as one activity is done or one task is done, it gets displayed in your screen. So this, you can see this is status. The first step is done, which is Microsoft Insights. Then there are other aspects as well, but it's still running. So there are also a few more things which needs to be done. So that's why it is saying it is still in progress. Let's wait for maybe 10 more seconds and see what more we can get. All right, so deployment is complete. Okay, and you can see that you have some details like deployment name and correlation ID to start time when you started this running activity. Okay, and then there's the resource group which we have selected as MLOps, and then there is subscription. Okay, so everything is done. So now we'll go to resource which we have just created. Okay, so now you can see this is my resource which is created. So I need not worry what this is. It's just the details of what I have just provided as an input. Okay, so these are the same essential details which is there. Now the studio thing is the one thing which we have to go to build our model. Okay, so you can see at the bottom section there is launch studio. to work with your models in Azure Machine Learning Studio, you have to click on this Azure Machine Learning Studio. Let's click on this Launch Studio. All right, so this is the same page, which if you remember was there in your presentation as well, right? There are 4 sections: create new, notebooks, automated ML, and designer. Right? What more things we have? You can see there are on the left-hand side section, there is notebooks, there is automated ML, there is designer. So these 3 things are again there here. If you click on notebook, you'll see this page, okay, where it is asking you to create a notebook or terminal. So let's create one, create a new file, and let's say write it as practice MLOPs, right? And then I want it to be IPy file. I can have these files as well. Okay, R bash text file. Now let's create one. Right. So this notebook has been created. Correct. Now here you can write your code. Suppose if I want to write anything like print hello, I'll just write Shift Enter and it will run. Okay. Now you'll see that this is not giving you any output. Why? Because we have not selected any compute. To run this, we have to have some RAM and some SSD, right? Some GPUs, some CPUs, but we have not selected anything. That's why it is not throwing us any output, right? But this is how you can create a notebook and start writing or start scripting your workflow, right? Then there's automated ML, which can obviously click and see how you can create a new model. And to know more about this automated ML, you can just click on these things. It will open in a new page and study about it and build a complete automated ML pipeline. Then there is designer section. I just quickly walk through each one of these. Designer, where you can see there is, if you want to create a new pipeline or you want to use a pre-built maybe ML models pipelines, like there is one image classification using DenseNet, there is binary classification, then there is wide and deep based recommendation engine, then there is regression automobile price prediction. So which we looked at in our presentation. So we'll be studying this designer quickly and see how the deployment works in a real life scenario. Okay. Apart from these things, apart from these 3 notebooks, automated ML and designer, there are also other assets which we looked at in the presentation. There is data sets. If you click on this data set, there is section where it says if you want to create a new data set or you want to explore it maybe from other GitHub repository. You can click on this and see if you want to import from your local files or from other data store which is present, or from any web files or from open data set, you can choose it from here, and accordingly you can use it in your pipeline. Okay, so these are the data sets which you can use. Then there are experiments which you can create. Okay, this is just basically a folder kind of thing. Experiment just means basically what different experiments you want to do, right? Which we just looked at in the presentation. If you want to build a separate model and with separate hyperparameters, you can put it in a one experiment. If you want to build another combination, if you want to build another model with some other combination, you can put it in another experiment. So likewise, you can create new experiments. Okay, so you can click it here and you can create new experiment according to your plan. Then there are pipelines, right? So there is currently no pipeline present because we are not yet started, right? Then there's environment. So this is the kind of environment which is available right now. All right. So you can see for each environment which was already created. This was created on April 20th. Okay, version 26. So this was probably created by Azure ML by themselves. You can see that it's created by Microsoft itself. So they probably they're working on some environment right now with such GPU, with this OS, with this tool PyTorch, and they are currently training. And this is you can see on the right hand side, you can see the description of it, an environment for deep learning with PyTorch containing Azure ML. So you can see how this environment gets created and eventually how this can be looked at in Azure website. Okay, so this is the ML.Azure Studio website, okay, which gets open when you click on Launch Studio. Okay, so in this particular website or in this particular link, you can see all these stuff, all the environments, all the pipelines, all the experiments, all the data sets. Right? Then if you click on models, there's certain models which you also can build. There are endpoints like that. Okay, so there are several sections in assets, okay, which you can explore and learn separately how you can use all of these things in the pipeline. Okay, apart from this, there is more in the studio, where the first important thing is compute. Okay, because we spoke about compute here, and when we were running notebooks, it was not running because we had not selected any compute. Let's create one compute. Okay, before that, I'll just quickly show you what data stores is. So this is what a data stores look like. Okay, so whatever data you register it in MS Studio, it will get seen in data store. All right. Similarly, you have linked services. Suppose you want to add any integration from other platform, you can use the service to integrate that. Let's go back or come back to your compute section. Let's create one compute. We'll create plus new. Just quickly go back and reiterate this. In this section, there's manage and compute. Okay, and then we wanted to create a compute. Right? So we'll click on compute. And when you click on compute, there are 4 things: compute instances, compute clusters. Okay, if you want to scale your compute cluster for a single node to a multi-node workload, suppose you have multiple data sets to work on, a very large data set to work on, or you want to have maybe scale this thing to a different possibility, maybe with a lot many features, lot many parameters, you can do this with compute clusters. All right. So this is the compute cluster, and then there is inference clusters where you can deploy your model to Azure Kubernetes service for large scale inferencing, and then there is attached compute, which you can also do to your current compute. Okay, so you can bring your own compute like this. Okay, and then you can attach it in your workspace, or you can use the first tab, which is compute instances, where you can use the Azure specified or compatible computes with you. So you can use the inbuilt compute available with you. You can select one of them and use for your particular model. Let's click on this and see what is coming out. So when you click on plus new, we get this page where it says these are details which you need to input. All right. So what it is asking you to first give a compute name. So you can give any compute name. Let's say I just say practice MLOPs. Sorry, giving the same name. So let's create a practice compute MLOPs so that there is no confusion. Okay, so I've given this name. Now I've said the location is auto-populated because we had created a workspace within this particular region, correct? And now it is asking me to select virtual machine, whether it's to be CPU which you want to use, whether you want to use GPU, you can select accordingly. Okay. Then finally you can select from the recommended options what compute you want to use. So if you're using a correct location, a correct region, you will be able to see this. If you're not using correct region, not correct, basically sometimes some machines are not available in a particular region. So you can change your region and see if you can get these kind of options. Okay, so I've selected Australia East. You can see if you can select any other region and see get a similar result. So out of these 4, it says that this is the standard one, which is for the general purpose. Okay, this one is more optimal, more memory optimized, and similarly for this and this. Okay, so if you see, this is having only 2 cores. This is having 4 cores. This 4 cores is also 4 cores, but there are different RAMs and different storages. Okay, so accordingly you can select, and for each of the options, you will have some cost involved. There's 0.2 per dollar, 0.34, 0.4, and 0.22. Right. So second one I've selected because it's for general purpose. It is for classical ML model, and we're not building any deep learning or any other model, reinforcement model. Correct. We're only building a simple classification ML model on small data set. So let's click this. Okay, it will have 6 cores. It is the available quota, and we're going to use 4 cores out of this 6 cores. All right. If you click on next advanced thing, you'll be able to see all this: enable SSH access, enable virtual network, all these things. So you need not change any of this. You can just directly click on create. When you click on create, it will start creating, and you will probably have to wait a little amount of time for this to get created. This will create your computer instance. It will basically align or assign one particular CPU or GPU which you have selected to your particular project. Okay, so it will take some time to create this one so that you can start working on it. If you click on notebook again, okay, and type print hello and click enter, you will not get result because it is still not yet created. So once it is created, you can go back to your notebooks and start running your experiments. Let's wait for maybe 10 more seconds and see if it gets created. Okay, I see one question: if this is a container image or a VM image. I'm not sure if everybody is on the same page of this particular knowledge that what is the difference between a container image or a VM image. Basically, containers something which it basically helps us to visualize any operating system. Okay, so that all the multiple workloads can run on a single OS instance. But with VMs, with virtual machines, the hardware, it's being completely virtualized to run on multiple OS instances. That is the prime difference between a VM and a container, right? So I'm not sure, Ranganath, which slide we were talking about, but this is the image, and we were talking about, I think, container image and VM image separately. Yes, it is related to environment. That's right. Okay, so now you can see that our compute has been started running. Okay, it has started running, so that means it is created. Okay, so now we can work on any model or any notebook, either no code or with code. Okay, so if we go back to our notebook section, you can see here, you can see in compute instance, if I can select this, you will see that this is what is already selected because we have created this particular compute. Okay, so it will tell you that it has 4 cores, 14 GB RAM, 28 GB disk, and this is the price per hour. All right, so I will select this, okay, and then rerun this. You can see you will get an output which is hello. All right, so it is running in that particular instance, or in that particular compute instance. All right, now let's go to designer and see how this model looks like when there is a no code environment. I click on this, so you'll see it's asking to first create a default compute target. So I can just select this one, all right, and just start working on this. So I'll just remove this. Okay, now you can see there are some nodes which is present here. So that's how your canvas looks like in designer. So when you click on designer, this is the canvas which you will get, where you can start working on your particular model. So you can see everything is connected. Okay, and it starts with your data. Okay, first of all, where you start giving automobile price data as your input data. If you want to do this manually or separately, you can just go to the search bar and you can start typing automobile. Okay, so this will come here. You can just select this and drag it here, drag and drop it here. Okay, so it will tell you a description that what this data is about, what is the description, and what is the path. Right, I'll just remove this. You can drag drop this data here, and then for each of the node you can do this again manually. Okay, so you can just for this particular node, you can, it says select columns in data sets. Suppose in this particular data set you want to only select limited number of columns, so you can just go back here in the search bar, you can write select columns, so it will tell you that these are things which are available. You can just click on this and drag it here. So this it's giving you this warning sign because it is not connected, so you can just connect it from here to here. Okay, and then you want to see that what this data is about, you can just click on this, just right click and preview data. You'll see the entire data like this. All right, so this is what your data looks like. You can just expand this also. So the first column is symbolizing, then normalized losses, make, fuel type. This is all the details of the automobile price. Okay, the number of doors, body style. I think it is reserved for each of the car. All right, the drive wheels, the engine location, wheelbase, length, width, like that. The final column is your price which you are going to predict. So based all these features which are present before price, these are all your independent variables or independent features which you are going to use to predict your final column, which is your price column. Okay, so this is what your data looks like, and if you can see, there is kind of histogram plotted for each of the variables. So for price, you can see there is it's probably the right skew, correct? Similarly, you can have some observations for all of the variables. Some variables are normally distributed, some are only having 2 categories, so it is probably a bar chart, correct? So like that, you can have some observation that what this data which we have looks like. Okay, now we'll just connect this node, and then here you can just, it says the parameter select columns is invalid because we have not selected any columns, correct? You can just right click on this, and then you can start working on this particular data. So let's first click on this. These are settings which you can make. Use default settings, run settings, like that. What node you want, what Docker you want, you can work on this, but it is not very much required. The only thing which is required is what columns you want to select. Okay. So this is not possible yet because we have not run it yet. So we have to first select and run it so that it just runs properly. So you can select here because this is properly running, okay, in this canvas. Okay, and then here you can just connect this node to this one, and then start running this. All right, so just delete this one, old ones. So once you connect this node, you will see that this is no more the warning sign is no more there. Okay, so just submit it, it will run, Okay, and then similarly you do this for all of the nodes. So secondly, you then start with your data exploration or data engineering. So you want to do a clean missing data. So whatever data is there, you can specify what values you want. Okay, and then you can see what options you're getting. There's copy, there is delete, there's view log, and there's access data. So once you run this, by clicking on submit, it will run, and then you'll be able to visualize this what has been cleaned. All right. Similarly, for building a machine learning model, suppose it's a linear regression model, because our output variable today is continuous. So we'll be building a linear regression model and not a classification model like a logistic regression or any random forest classification. Correct. We'll be building a simple linear regression model, which you can just type in here again, and then you can select it from here and just drop it in the canvas. Okay. Once you drop it, you can again just connect it here, and then you can connect this thing. And then similarly, before, as you know, before you train your model, you always split your model into train and test. You can type in here and split. You can drag it here in your canvas. You can split your 0.7 into 0.3. Okay, and then all nodes then can get on selected. Okay, once you select all these nodes, which is basically ends at evaluate model. Correct. You first train your model, and then you score your model, and then evaluate. I hope you understand what this is. Right. First, you start with training your model, where you try to derive an equation of a linear regression by understanding your data or by training your model, where you get an equation which is somewhat like y is equal to mx plus c. Correct. Once you get an equation, you can then use it to predict on a different data. So now we are using this score model node to predict it on test data. That's where you can see this split data is connected to score model. Correct. So I'm trying to predict on test data. That's how it is. That's where it is getting connected to your split node. Okay, so I connect the split node to score model, and then I score it, I run it, and then I connect it to evaluate model, and then finally everything gets evaluated, that what is the model's performance, and it is stable or if it is not stable. Okay, so let's just, since everything is now properly connected, I'll just quickly run this by clicking submit. When I click on submit, I'll get this dialog box, where it will say that you want to create a new experiment or put it in an existing experiment. So you can just select this. So you can see that when I click on drop down, there's nothing which is coming out. So I'll just create a new experiment, which is, let's say, new regression experiment, okay, 01. Just create this new experiment by clicking here. Let's say exp01. All right, so let's create this. Click on submit. Okay, so now you can see it is running. All right, on the right hand side top corner, you can see it says the pipeline run. It is still running. Okay, it is loading. So once it is run, it will give you the entire result. You can click on any node and observe the results. All right. So now, as soon as we click on run, you can see it's saying running, and it is now at the first node. To say that it is not yet started, because it is probably at the import stage. So it is in the first node, and now it says it is queued. The second node is now running. All right, and if you want to know what step it is running, you can click on view run overview and see where it exactly is. Okay, so there are a lot many things like attributes, pipeline parameters, metrics, child runs. So you can see that it is running. Right, it's been 21 seconds since this part is running, and this part is running. It is not completely very clear to our naked eyes that which part this is. Epic line means what and silver pane means what. Okay, this is just a display name, but you're looking at this, we can still understand that it is running probably these two steps. Now just go back, you can see this says it is running. So we are now at this particular node. Okay, when you run this particular model for the first time, it might take a little more time, because you're running it for the first time. All right, but if you run it for the second time, it will run slightly faster, because now it knows that what transformations or what treatments it wants to do. Okay, so when you run it for the second time or a third time, it will run a little faster than what it ran and the first go. All right, so since we're running in the first time, it will take slightly more time. So let's wait for maybe a couple of more minutes and see what results we get. Okay, there is one question. What is evaluate model? Evaluate model basically is the same thing which we saw it in the presentation, where we are trying to see the model's performance for both train and test. So we're trying to see if the both performances are stable, or both performances are maximum or not maximum. we click on evaluate model, we look at this one once it gets completed. In a regression model, we'll probably look at R-square value or RMSE's values to see what model results are. Okay, if it is a good R-square of a very high R-square, we can say that the model is able to capture large amount of variation in my dependent variable. So model is a good model. Okay, similarly, we check the same R-square in your test data and train data. We compare both of them and then finally evaluate. This is what an evaluation is. So you are evaluating your model basis your model performance metrics. So you use these metrics to finally conclude that whether your model is good fit or a not a good fit model. One more question is, can we give multiple models and find out the best most suitable model? Yes, you can. Here we have only used regression model. We can also use any other model, and we can drag it here on the right hand side of the canvas. Suppose I select random forest. The random forest is not there. Decision tree forest. Okay, you can just drag it here. I think it is not happening because it is still running. Okay, let it run. Then what you can do is you can just select this and drag it and drop it in the right hand side of the canvas. So you can select again that node to your train model, and again both the models will then run parallelly. So once this linear regression gets completed, it will select random forest or a decision tree forest, and it will run that also. You can select multiple models and put it in canvas and see what performances you're getting in all of those models. What is the difference between score and evaluate models? All right, score is just to predict your outcome. So once you get a different data, suppose in this scenario you have test data. Okay, you built your model on train data, correct? So that is called training. And when you score it, basically you're using .predict function in Python, or you're basically using that trained model equation, which is y is equal to mx plus c, to predict on a new data set. So this prediction is nothing but your scoring. This is the same word. Scoring means basically predicting it on a new time point. So here we're predicting or scoring it on a new data set, which is test data set. And once we get this scoring, once we get the y hat or y estimated or my estimated price column, I compare this estimated price column with my actual test data sets price column and see what is the difference. If there is an error, then what amount of error am I getting? Okay, that is now there in your evaluate. So that is the step where you evaluate your model and conclude whether your model is a stable model and whether you are getting good performance or a bad performance. Right, you can see we have now come to train model. It says it is running. All right. In this top right corner also you can see it says running. So we are at this particular node. Once we are done with this, we will be going to score model and evaluate model. Let's wait for a couple of more minutes. I hope, Ranganath, I have answered your queries. The score is just to predict, Ranganath, where we're just getting a y estimated value. So we already have y actual value, correct? Which is my in this particular example, it is price column, correct? That is in my actual data set. Now when I make a prediction, I will get one more y column, which is my estimated y, correct? That y new estimated column comes using from your score model node. Once I run the score model, it will use the train model's equation to predict it on a new data, which is test data, and provide us a new column, which is my y estimated. This is nothing but scoring. Okay, once I get this, I'm done with this node. Then I move on to the evaluate mode, where I'm comparing both the columns, y estimated and y actual. That is where evaluate model comes into picture, where we're comparing both the columns and again checking the performances of entire test data set and then for train as well. Now score model is finalizing. You can see it says finalizing. And now we'll move to evaluate model. All right, so it's now says it is completed. You can see model has now been evaluated. Now if I click on this, I just right click and see register data, it's evaluation results. Okay, so you can basically it is about registering your data. Okay, so whatever evaluation you have done just now, you can move it to your data store. You can by registering your data sets. So whatever evaluation results which you have got, okay, you can create as a new data set by writing your data set name, and then you can move it to your data store. Okay, but we're currently not doing data we're not registering our data. We'll just access this by we can click on this. It will open in a new web page. Okay, so this is where you will get all your of evaluation results. So it has data visualization, data sets, and samples and metadata, everything. Okay, you can just explore this and see what different results you get. Okay, let's come back to this particular node. And right click at this data. I'll click on preview data and I can click on evaluation results. When you do this, you can see you have mean absolute error, which is nothing but your comparison of y actual versus y estimated. All right. So it says you have 1773 price of your automobile car, which is your average error, which you have got, which is absolute value. Okay. So plus or minus, you are this much far from your average error. Okay. Then there is root mean square error, which is nothing but your square root of your mean square error. And then there is relative squared error again. Okay, it's just a relative, just a formula which is calculating your relative comparison between your squared errors. And then finally, you have these things, which is relative absolute error. But these things, all these things, you can just select any one or two of them, which metric you want to choose, and accordingly decide if your model is a good model or not. The first thing which we look at is R square, right? Coefficient of determination, which is this one, which says you have 0.868204 value of coefficient of determination, which is your R square. What is R square? The amount of variation which you are able to capture in your Y variable, correct? So 86% or 87%, you can say you are able to capture variation in your Y variable, which is very good. Okay, so this is the data, this is the performance of your test data. All right. Similarly, you can do this evaluation on your train data as well, and then compare that. But suppose you're getting an average, if I again click on this evaluation results, so you can see here you have mean absolute error of this much for test, correct? So you can have similar mean absolute error for train data as well, and then you can compare both of them. Suppose mean absolute error of your train data comes out to be 1500. Okay, so you can see the difference between them is not much. So accordingly, you can decide if your model is a good model or a stable model or not. Okay, so this is for your regression model. If it had been your classification model, the results would have been slightly different. You would have gotten maybe a recall or a precision and an accuracy, and then you have again evaluated your model basis those parameter metrics. Right. So I'll just close this. Again, you can explore all this thing. Okay, you can view log, you can copy, delete, and access this data and evaluate your results. If you want to look at score model, you can just right click and access your data, preview your data, score data sets. When you click on score data set, you can see again you have same data set, okay, but you have again one more column, which is your estimated column, right? So this is the second last column is your price column, which is your actual data. So it says your actual value was 69639, but your estimated value or your scored value is 10,909. So you can just subtract both of them, and you can understand how inaccurate you are in predicting your price column. Correct. Similarly, you can do this for all the column or for all the rows. Correct. Right. And that's how we arrived at the root mean squared error and mean squared error. So we compared both of these columns, which is actual price versus estimated price, and then arrived at those errors at R square. Correct. So this is how you can understand this entire canvas. You can click on each of these nodes, understand how these things are working out for you. So this is not just a limited step. There are also many steps which one can do. There is hyperparameter tuning. There is more types of cleaning which you can do. We have just done missing data. There is outlier treatment which also you can do. So you can explore all these things here. You can just start typing and see what more things you can do. Okay, like here there's machine learning algorithms. Right, if you click on this, you understand what type of regression algorithms you can try. Okay, there are a lot many algorithms. Then there's unsupervised algorithms also, right? There's k-means clustering. Then there's other classification algorithms, correct? So there are a lot many ones. And then you can just minimize this and look at other functions like statistical function. You can just summarize your data and look at what basic descriptive statistics you have, like mean, median, mode, percentiles, all those stuff, right? So to understand data before we start building, you want some time to know what our data is all about, correct? What distribution they follow, what is my average, if it is negatively skewed or positively skewed. Accordingly, you take decision whether you want to add one more column or drop some columns, right? So before we start building, which is at this stage, if you look at this fourth step, which is linear regression, there are three steps which we have done, but there can be more steps where we are trying to explore and engineer more in our data and try to get a more structured and more clean data for us to use in our model. So you can do all those stuff. Like there is also feature selection, right? This feature selection, suppose you have a lot many features in your data. Let's say it has maybe more than 1,000. So you want to probably reduce this particular dimension from 1,000 to maybe 30 or 40 variables in your data, correct? Because 1,000 will be very large in number, and that might impact your model performances, as well as it might tend to overfit your model. So you want to reduce this particular dimension, and to do that you can do a feature selection method by using these probably tabs and put them into canvas and see if you can reduce these dimensions to any maybe limited ones. And then eventually, after you've done with that step, you can start with your model building process, which is linear regression or a random forest or any algorithm. So you can just start exploring. There are many I think names and tags available here. You can start exploring and see, try drag dropping them and rebuild your model. That if that step can improve your performance, because now you have a performance of 86% of R square, correct? But in order to improve that or maximize that particular performance, what more you can do? You can explore all these things to do that. Okay, to maybe stabilize your model more or improve your performances. Now, coming back to this particular canvas, now we're done with the model building exercise, right? So once you're done with this, we have to deploy it, correct? To deploy it, you can just click on this, create inference pipeline. There's real-time inferences and there's batch. So you want to do it real-time, or whether you want to do it batch-wise, like maybe every 4 hours or every 12 hours, like that. You can select any of them. Let's click real-time and see what happens. Since they are deploying it for the first time, it is taking slightly more. Otherwise, it doesn't take much time, but it also depends what data set size you have. So we don't have a very large compute. That's why it's taking slightly more time. If you take more compute, it will be done in a very quicker time. You can see there is one more node added, which is web service input. Right. So there is one input node added and then one output node added. So this is to deploy your model. Okay. So this is how you can understand. Okay, now a model is ready for deployment, and you can just now click on deploy and deploy it wherever you want. So now we have not created any service. So we'll just leave it at this stage. But once you're done, once you have created a service, you can just click on deploy and deploy it on a maybe real-time basis or a batch-wise basis. Right. Now, if you again, this is how your no coding experience looks like. But if you want to do this similar exercise in a notebook, you can click on notebook and start exploring your entire modeling process using scripting. So this is all your Python coding. If you want to do any R coding, there will be different tool which you have to create here. Because you click on plus sign here, which says you want what file you want to create, right? And here you can select if you want to build your model using R or any other tool or any other scripting language. You can do that as well. Let's cancel this. Okay. Now, once you're done with this, okay, once you're done with everything, deployment, all this part, and you know that now your model is properly deployed, and you do not further want to use this particular service because now your model is already saved. All right, so you can just close this entire thing and stop your compute. Otherwise, just if your compute is still running, just click on this compute. Your compute is still running, right? And if you leave it like that, you might get charged because your model is still in, it is still live and it's still probably taking information from your data and trying to, it's basically ready for deployment. It is still taking some amount of your CPUs and GPUs. So it is better to stop it. So just click this and stop it. Once you click on stop, it will tell you that this is trying to stop your compute. So it is very mandatory, or it is important to stop this. Otherwise, you might get charged improperly, and that will not be good for us, right? So it's better to stop it, and then you can also delete it if you do not even want this compute anymore. You can delete it. So it's very simple to create a compute for you, right? So you can just delete it, and whenever it is required, you can go on to the compute section and then create a new compute. So it will take a little time to stop this because it is basically trying to stop it at their server, which is available with Microsoft. It takes little time. So now you can see it is stopped. You can again click it and delete it also. So it is deleted. Similarly, for designers, you can see there are several designers or notebooks which you have created. You can go back to those experiments and then delete them too. So you can see in experiment section, you have this experiment which you have created. You can click on this one also and delete it. It might not be required, right? So you can here there's no delete option for experiment, but you can still archive it. But if you want to delete it still, you can move to the other sections and see what more things it is available. So here in pipelines, you can see there is this pipeline which you had created, correct? There is this set of environments which you have created. You can click any of them, or whichever you want to delete. You can click all those environments and you can delete them. Now this you cannot delete this because this has been created by Microsoft. You can only delete those which have been created by you. Correct. This is what I think it's all about, your Azure Machine Learning Studio. Okay, and I request you to explore this by just starting the demo trial for 30 days and see what things are available. You can try different regions and see what computes are available for you, and you can start working on it. Once you're having a thorough hands-on experience, you can then start exploring with a pay-as-you-go option. All right. So this is, if you go back to this home page, you will see that this is it will tell you that these are the again 4 tabs which you can explore, and these are the recent resources which you have worked on. That's it. But I hope I think this session was useful for everyone. I'll just try to answer the last few questions which are available over chat. So there's one question: how to connect this model with real-time data? So that we just saw, Sumit, right? You can click on real-time inferencing section, and once you select that, it will ask you that whether you want to do it real-time or batch-wise. And once you select this, it will create a new service. But we have not created any new service, right? There is a linked services section available, so you can do that by linking that particular service, web service, to that particular node which we left. So we did not go beyond that because we do not have any services created. That's why we stop. But if you have a service created, you can deploy it accordingly. So for that, after this section, there comes IT role, there comes ML engineers role, where they will help you out in this particular deployment. There's one more question which is a good model with code or with no code. Mayur, there's I think there's no I think comparison, I would say, because some people are comfortable with code and some people not comfortable with code. That's why we have both options available in Azure. Okay, if you have the advantage in code, I'll tell you the advantage, but sometimes even with no code, people are able to get those high level performances. The advantages in with code is you basically can tweak things wherever you want in your code, right? Suppose I'll give you one example. Suppose you want to increase the speed of your car, but your car has broken down. You do not know. Now you're not a mechanic, right? You're a proper driver, you're an owner of the car, so you know how to increase the performance of your, or increase the speed of your car by just accelerating, correct? So once your car broke down, the only thing which you will do is just accelerate, correct? Because you only know that part. But if you are a mechanic, you will also know that where it went wrong, okay, which part is not working, which probably if cylinder has not working or something else. So you can go back, you can open your maybe your shutter, and you can inside the shutter you can see what went wrong, if there's no water, if there's petrol gone wrong, something, because now you're a mechanic, right? You know all the parts of your car. You can work on, or can look at all these parts and see where it went wrong, and then you can try rectify that, and then finally close that shutter, and then you'll see that your car is not running, and now when you accelerate, your car will have a larger speed, correct? Probably. So that's the difference between the two. When you have no code experience, you'll just probably put on acceleration. But when you have a coding experience, or when you know how to code, you can tweak things wherever you want and increase the performance in a more I think better manner. Okay. So the difference will be obviously with code you will have more advantages. With no code you will have less advantages. But sometimes with also no code, people are able to build a very good model, because with no code experience we have, or Azure has made it so much easier for us. Okay, it is not just that you just have to accelerate your car. There's many features which was only available to, let's say, mechanic. Now it is also available to driver as well. So now driver also has control what other things they can tweak and increase the speed of the car. Okay, I hope this example was good enough for you to compare what is the difference between no code and code. Right. So Azure has made this possible, where even for no code, where people with no code experience can still build a very good model. That's it from my side. All right, thank you everyone.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job.